Hello and welcome to our video on systems of equations. What we're going to do today is talk about the different ways to solve a system of equation. So welcome. So we're going to start with the cat chasing the mouse problem again. The cat is chasing the mouse. The cat runs 6 feet per second while the mouse runs 4 feet per second. The mouse has a 10-foot head start. How long will it take the cat to catch the mouse? How far from the start will the cat catch the mouse? So as you can see in this problem, we're looking for two variables. We're looking for how long will it take and how far. Two different variables. So let's move on. So we're going to try to solve this problem first by graphing. We'll use red to indicate the cat and blue to indicate the mouse. Also, I want to label each axis. This is going to be time and distance. And we're going to change the scale and the distance to make it fit here. So each square counts for 4 feet. Alright, so if the mouse has a 10-foot head start, that's going to be 4, 8, and we'll put this somewhere in the middle of where our y-intercept is to represent the 10-foot head start. And then the mouse runs 4 feet per second, so it's going to go up 1 square over 1 each time. Up 1 square over 1. Up 1 square over 1. Up 1 square over 1. And we're going to have a line that looks just like that. It's not very good, but you guys get the point. So that is the mouse's line. The cat does not have a head start and starts at 0, 0. Now the cat runs faster, 6 feet per second. So that's going to be a square and a half each second. So up 1.5 over 1, up 1.5 over 1, up 1.5 over 1, up 1.5 over 1, and once more up 1.5 over 1. Oh my gosh, right there is where the two lines intersect. You're just gonna have to believe me even though it's not perfect. This is also a reason why we use graph paper and we draw with better tools than what I have in front of you. But where these two lines intersect is the solution to this equation. And if you want to look at more detail, this is why solving with a graph is not always the best way to go. So we're going to look at how we can solve this problem algebraically. So let's try to solve this equation by substitution. So we're looking at two equations here. First, the cat's. The cat's distance is equal to, since it doesn't have a head start, doesn't have a y-intercept, 6 feet for each second. So the cat's equation is d is equal to 16. Now the mouse, also looking at the mouse's equation, the distance is equal to, well, the mouse runs 4 feet per second, plus has a 10-foot head start. So that's supposed to be a t. Since we have d equals blah 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 in the cat's equation and d equals blah 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 in the mouse's equation, then doesn't it make sense that d from the cat's equation should equal d from the mouse's equation? I think so. So, what we can do to rewrite this equation with only one variable, we are going to write not what d is, but what d equals. And on this side of the equation, we're not going to write d, but we're going to write what d equals, because again, we are substituting. And we can solve this equation because now we're just down to one variable. And in order to solve that, we do the opposite. So when we do that, we have 6t minus 4t. I'm just going to move this down just a second. That will give us 2t equals, this is a hua, You guys have been missing that on the videos. 2t is equal to 10. Of course, we want to get t by itself, so divide by 2. And we get t is equal to 5. What that means is the cat will catch the mouse in 5 seconds. Now that's not all that the question asks for, because it also wants to know how far. So how do we figure this out? We can either plug it into this equation or this equation, whatever seems easier to you. I'm going to plug it into the cat's equation because that seems easier to me. So we have d is equal to 6, but we know what t is, so we're not going to put t in there. We're going to put what t equals. In this case, t equals 5. So the distance is going to be 6 times 5, which equals 30. So the cat will catch the mouse in 5 seconds, 30 feet away from where they started. Time to take a brain break, and what I want you to do is look at this picture. It's really cool art, even though it might look like it's three-dimensional and the shark is jumping out. That's all just a chalk drawing, and they mess with proportions to make it look three-dimensional. So how cool is that? Rah, sharks. The third way to solve an equation with systems of equation is with elimination. The basic idea behind elimination is we have two equations, two variables, but if I combine them with either adding or subtracting, I can find a way to eliminate one of the variables. Easy way to spot an elimination problem is if you see something like this. We have a negative y and a positive y. That is great because if you just add down, we have the opposite of y plus positive y, that is 0y, or like what we like to say in class is a wha. So if you're going to add down with the opposite of y plus y, that's going to be 0. 5x plus 3x is 8x, again adding down. And over here we're going to continue adding down, and we have 0 plus 24 is 24. Oh my gosh, this seems so easy, because if we just divide by 8, x equals 3. Are we done? Well, not exactly. Because now what we have to do is take that, plug it in, solve for y. I'm going to plug it into the second equation. So we have 3 times 3, because instead of writing x, we're going to write what x equals, plus y is equal to 24. Okay, 3 times 3 is 9, so we have 9 plus y is equal to 24. If I subtract 9 from both sides, I get y is equal to 15. So we've solved our equation. If you're not sure, you can just go back and check. 5 times 3 is 15 minus y is 15. That equals 0, so check. 3 times 3 is 9 plus 15 is 24, so that's a double check. It worked for both equations. So we have another system of equations that we can solve with elimination. But I'm a little confused because when I look, these two variables, the y's, have opposite signs, but the coefficient is 8 and 9. If I just add down, nothing's going to disappear. 5x and 3x, that looks, they're both the same sign, and if I add down, those aren't going to disappear. So I can't add them, I can't subtract them. But wait, what we can do is make sure that they are the same by looking at the same factors. So I see 8 and 9. Okay, I can get them to be the same number if I multiply this entire equation by 8. Whatever I do on one side, I have to do the other. I can get this whole equation to match the equation above if I multiply this by 9. If you don't believe me, we will see. So this is going to be some distributive property. This is a hua. 8 times 5 is 40x minus 8 times 9 is 72y. And negative 43 times 8 is negative 344. No, I did not do that in my head. I had a calculator and I hit pause like I'm about to do now. You can figure it out yourself, the next equation. So, what'd you get? I got 9 times 3x is 27x. 9 times 8y is positive 72y. Oh, I see something. And over here we have 9 times 68 is 612. Okay, so now this is interesting to me right here. Because look, now we have a plus and a minus. So if I just add down, 40x and 27x is 67x. Negative 72 and positive 72y is, guess what? Wah! That was an extra long wah. And negative 344 plus 612 is 268. Now, obviously, when you divide both sides by 67, yes, that is my calculator that I'm using, that you hear, you get x is equal to 4. Are we done? Well, not quite. But what we can do is plug into either equation, whichever seems easier. I'm going to kind of clear off some space here. We know that x equals 4, so I'm going to plug it into the first equation. And I'm going to make it 5. Instead of writing x, I'm going to write what it equals, 4 minus 9y equals negative 43. 5 times 4 is 20, minus 9y equals negative 43. Okay, we can solve for y by getting the variable combined. Let's see, so this is a wha. Negative 43 and negative 20 is negative 63. Negative 9y, we divide both sides by negative 9. And we get y is equal to, negative divided by negative is positive, y is equal to positive 7. So we have a correct answer here of an ordered pair of 4, 7. Yay, we did it. So that's our video. It says summarize your notes. What I'd like you to do is go back, look through the foldable we made, use that as a study guide. Look at other videos. If you didn't like my video on Elimination or other places on the internet, ask questions. Please don't fall behind in this chapter. This is a very important chapter. Alright guys, have fun. I'm going to leave you with a little bit of music. You can